Hi everyone. Today we're going to introduce probability or a theory of probability. Okay, so in today's video we're going to give you several concepts. First is about random variables. That's some tools that we use to describe random events or random outcomes. And then we talk about expectation and variances of random variables. So those are some important descriptive measurements that we may do for random variables. And then we spend some time to talk about continuous distributions and in particular normal distribution as one of the most important distribution concepts in statistics and data analysis. Okay, let's start. So in this video, I'm going to talk about random variables. As I mentioned, it's a way to describe a random event. So technically, we say a random variable is a variable whose outcomes are random. So in the past, when we were young childs, we know that when we want to do some algebra, we need to define some variables. Those variables, their values are certain. But for random variables, they are not. Here are some examples, like if I toss a coin or roll a dice, the outcome of that is random. So the outcome of tossing a coin is a random variable. The outcome of rolling a dice is also a random variable. The number of consumers who will enter my store at a particular time period, that's also random. Finally, the temperature of a classroom at tomorrow noon is also random. So there are always some things that we do not know for sure. Then we may measure them as a random variable. There are two kinds of random variables, either discrete or continuous. The difference is that, first, in the way that those values can be obtained. For a discrete random variable, its value is typically counted. So I can count the outcome of tossing a coin. I can count the number of heads or tails. The outcome of rolling a dice, I can count the points I get on that face. Okay? And the number of consumers entering a store, I can count whether it's 0 or 1 or 2 or 3. But for a continuous random variable, its value is typically measured instead of counted. Okay, like the temperature of tomorrow noon, that's something to be measured. Or as another example, suppose I have a group of 100 students and I measure their average studying hours. Okay, that means I cannot count their hours. I can only measure their average hours. It doesn't really matter whether I restrict each of their studying hours to be integers. Okay, even in that case, I can count each student's studying hours. But when I take average, then that's going to be a tiny fractional numbers. Okay, and in that case, we say we can only measure that value. So a key point here is that counted and measured, they are not equivalent to integers and fractional numbers, even though in many cases they are, but they are not actually like that. Even if we have only fractional values that are possible, the outcome may still be counted, okay? So that's something to keep in mind. Counted and measured. So in another way, we say a discrete random variable has gaps among its possible values, but for continuous random variables, the outcome is typically forming an interval, so there is no gap in between values. So how may we describe a random variable? Basically, we need two things. We need to write down its sample space, which is the set of all the possible values. And for each possible value in the sample space, we need to decide its likelihood for that particular value to occur. Okay, so here the two things together form a probability distribution, or simply distributions. A distribution is also a very important concept in statistics, and at the beginning is a little bit not so intuitive. So let's spend some time to talk about distributions. As random variables may be discrete and continuous, Distributions may also be discrete and continuous. Let's first introduce discrete distributions, which is more intuitive. So, for discrete random variable, the task that we need to do is a little bit easier. We only need to list all the possible outcomes, and for each of them, list their probabilities to occur. Like, if x is the result of tossing a fair coin, then I know x may be either head or tail, right? Then if small x is head or tail, the probability for capital X to be small x is 1/2 for each outcome. So here, for this random variable x, possible values or the sample space is head and tail, and each of them I have the probability 1/2. So this table gives me a probability distribution. Let x be another random event or random variable rolling a fair dice. In that case, x or the sample space may be 1, 2, 3, 4, 5, or 6, and for each of them, the probability is exactly 1/6. So again, I describe a sample space, and then for each possible value in that sample space, I decide its probability. Then I have a distribution. The function, probability function, is sometimes abbreviated as just PR of x. That should map each value in the sample space to a probability, and that's why we call it the probability function of the random variable x. Obviously, for each small x in the sample space, the probability must be within 0 and 1, and the sum of all of them must be equal to 1. So here are some more examples. Let x1 and x2 be the result of tossing a fair coin for the first and the second time, respectively. In that case, if we consider another random variable called y, which is the number of heads obtained by tossing a fair coin twice, in that case, what's the distribution of y? Okay, so now to describe this random event y, we need to again write down all its possible values. Because we have two coins, or we flip one coin twice, then there are three possible values. Either it's 0 or 1 or 2. Okay, so that's the possible outcomes. And then for each outcome, we need to decide its probability. So we need to find the probability for y to be 0, 1, and 2. And the outcome is not so difficult to obtain. If getting one head is 1/2 as a probability, then getting two heads is 1/2 times 1/2, so that's 1/4. Similarly, if I want to obtain two tails, I need to get 1/2 multiplied by 1/2, so that's another 1/4. And that's why to get one head, I have the probability 1/2, so that the sum of them is 1. Okay? Suppose that today the coin is not fair, so the probability of getting a head is p, which is some number between 0 and 1, okay, but not necessarily 1/2. In that case, how may we describe the random variable y's distribution? Again, we need to decide the three probabilities. For 2, I know it requires me to have two heads. So x1 must be head and x2 must be head. In that case, I need to have p times p as my probability, because for each coin, the probability of getting a head is p. Okay, so two coins, that's p squared. For y equals 0, the probability is 1 minus p squared, because for each coin, the probability of getting a tail is 1 minus p. And the last part is a little bit more complicated. To get one head, I have two choices or two possibilities. Either x1 is head and x2 is tail, or x1 is tail and x2 is head. So I need to sum up these two probabilities. For the first one, I need to get one head at the beginning, so it's p, and another tail at the end, so that's 1 minus p. and so on for the second possibility. So together, the probability of getting one head is 2p times 1 minus p. Then this particular table gives me the probability distribution of the random variable y. Okay, let's consider another example that may be more interesting. It's about inventory management. So let's consider a story. Suppose that I buy apples and sell them to consumers. I can buy apples at $2 for each from the supplier, and I can sell them at $10 for each apple. Okay, then the difficult thing is that I don't know how many consumers will come into my store to buy apples. So I need to decide how many apples to prepare at the beginning of each day. And that means I am facing an inventory decision. I need to decide how many to store. Too many is not good, because then I may have a lot of leftover that are valueless. Too few is also not good, because then I am facing the risk of lost sales. Consumers may enter and I have nothing to sell. So to answer this question about how many to store, I need to estimate tomorrow's or each day's demand, right? And that's certainly random. So let's assume my tomorrow's demand is capital X, and the distribution is summarized below. And maybe that's something I estimated based on my historical sales records. So there is a probability 6% that there is no consumer entering the store and buying an apple. There is a probability 15% that one customer will enter. There is a probability of 22% that two customers will enter, and so on and so on. And according to my past experience, I don't believe that 9 or more consumers will want to buy an apple. Okay, then I probably want to visualize the demand distribution, so I draw a bar chart here. Okay, please make sure that you know this is a bar chart, not a histogram. Okay, so for each possible value, I can draw a bar to represent its probability. So very quickly I can see, oh, okay, so the most possible values are 2 and 3, and beyond 2 and 3 or below 2 and 3, the probability decreases. And I can also see that this is a right-tailed probability distribution, or I can say skewed to the right or positively skewed because there is a long tail at right. Okay, if we think about the distribution of y in example 1, then that's going to be a symmetric distribution. So I can talk about the shape of distribution based on this kind of graphs. Okay, so one reasonable question is about service level. So what's that? I want to ask, for example, what's the minimum inventory level that can make the probability of having shortage lower than 20% or a given level. Okay, I want to make sure that I have enough inventory so that it's not that possible that consumers will enter and find nothing. So I hope that my service level can be high, but I know if I have more inventory, that's going to increase my service level. But given a target, I don't want to store too much. Okay, so if I want 80% service level, what should I do? I need to ask myself, given any inventory level, what's my service level? And that's certainly the probability for capital X for my demand to be less than or equal to my inventory level. Okay, in that case, there's no shortage and I'm fine. So this probability distribution, or I should say this probability for capital X to be less than or equal to a given level, because that's used so often, we typically give it a special notation, capital F of X, and we call it the cumulative distribution functions. It's basically that given a level, say 5, I want to calculate the sum of all the probabilities for all values below 5 or below a given level X. So the service levels may be calculated for all possible small x. Like if I say x is 1, what does that mean? I'm going to buy in one apple, put that into my store, and count or calculate the probability for me to have no shortage. In that case, I'm hoping that there will be only 0 or 1 consumers, so the probability is 21. If I ask what's f of 3, then that's the probability for x to be less than or equal to 3. I have 3 apples and only less than or equal to 3 customers coming. In that case, it's 6 plus 15 plus 22 plus 22, and that gives me 65%. Or f of 4, that's 84%. Then I know my answer. To achieve 80% service level, I should buy in 4 apples according to this distribution. Okay, so knowing distribution or knowing probabilities helps me do this decision. Okay, let's stop here. Thank you.